So today is all the rest of the stuff about polynomials. So the very first thing I taught you was what's a polynomial and what's not. Is that a polynomial? Yes, it is. Even though it's only got one term, it's a polynomial. This is a polynomial of degree 3. No matter if this is 130 in front of it, the degree is the power. Now I just changed it. Now it says a degree of 7. You pick the biggest one, and then that's the lead term. Even though it's not in front, yes. There's a lot of weird exceptions on this, okay? So that's still the lead. Even though it's not in front, it's not on the left, it's still the lead. All right, now, you got to understand, sometimes we oversimplify things for you. Like when you were a little kid, your parents they didn't want to give you complicated rules about the street. When you were a little kid, they just said, don't go in the street, because they were afraid you're going to get by a car, right? You're playing in the yard, don't go in the street. They'd make a big deal because they could just see you running out there and getting squashed, all right? But do you go in the street now? Yeah, you go in the street because you know that you can if you do it safely, right? So life gets more nuanced the older you get. Instead of just black and white, wrong and right, it gets gray. Sometimes there's things like the speed limit where it's supposed to be going 55, yet if you have ever tried that, people just flying past you at like 80, and you're like, dang, I thought you're supposed to go 55. Well, it's kind of a gray area. Life gets gray. All right, so here's another one of those like oversimplify for you. If I say the one in the front is the leader, no, it's not always. So if I said 4x to the 5th plus x to the 7th, what's the leader? X to the 7th, okay. And so it sets the tone. It just tells us whether the story ends positive or negative. Do you get if this is positive? It must be going up at the end of its graph. All right, next little thing. Would you agree that this graph has 2 high spots? They are both high spots. Now, one of them does appear to me anyway to be higher than the other. And so let's talk about that. Let's say that this is at 0, 17, and this one's at 20, 18. Now we know for sure that they're both high spots, but one of them is highest. Now, here's the thing that confuses people. I can say they're both local minimums. And you're like, but no. One of them's more than just the local minimum. It's the overall minimum, maximum. You can say they're both local maximums, and one of them is also the absolute max. Absolute max means the highest of them all. Then this spot is a low spot. You know I'm not going to call that a maximum, right? What's it called? Minimum. Is it the lowest spot of them all? No. So you have to understand the difference between a local minimum, or sometimes they call it a relative minimum. This is called a local min. And in both of in this class and in pre-calc, the one that comes after this one, we call it a local min. But this new book is calling it a relative min. You have to know both words. They mean the same thing. Life's complicated. I wish there was just GCF, because that's what we do. But GCD, greatest common divisor, means the exact same thing as GCF. So it's confusing because there's 2 words for it. If you see a speed limit sign and it says 100, you might be like, there's no way to drive 100 in the U.S. Well, 100 kilometers per hour. So there are speed limit signs that'll say 100 if it's in kilometers, but that wouldn't actually be in the U.S. That'd be right across the border in Canada. They can go 100 in Canada. No, 100 kilometers per hour, which is pretty close. It's like 61 miles per hour, or 62. Okay, so this is an example now. Let's see if you get this. That is the point 12, -2. And this is the point right here, -1, 4. -1, 4. Okay. Is there an overall maximum on this graph? No. Might be like, well, there's this spot right here, but it's just going to keep going up. So no, there is no overall maximum. Is there a local maximum? Yes. And here's how you really define it when you're in a weird one and you're like, oh, is it a local maximum or not? The question is there in its vicinity, is there any point that is higher than it? No, if it's the highest point in the neighborhood, then it is a local max. Or the same thing for the low ones. Is there any point nearby that is lower than that? No, then that's the local minimum. So use that definition now on this one. That is the graph of y equals x to the third. It goes through that spot right there. Is that spot a local minimum? I'm hearing some people say yes and some people say no. You see how this is kind of a weird one? It's a gray area. All right. Now I'm going to give you another one that I'm not telling you the answer yet. I'm going to give you another one it's kind of weird. It stops right there. That's the highest spot. I'm not trying to make that a debate. If that is 1, 4, then that is a local maximum, period, because there's nothing higher than that. But what about this one? Is that a local minimum? And again, I have kids saying yes and kids saying no. All right. All right, you look up here. You got to be back in the game. You ready? Okay. All right, so I'll tell you the answers now, and I'll use my definition. This is an important definition. And you should ask yourself on both of these. Is there any higher or lower spot than the blue dot there? That should help answer the question of, is that a local max or min? Because if there's any nearby spot that's higher or lower, then it's not that special. It's not a local min or a local max. Same question here. Is there a spot that's lower than that that's nearby? Nearby, not over here. That's not nearby. Is there any spot that's near it that's... Okay, so then I want you to tell me, is that a local min? No, it is not. Because there's spots nearby that are lower than it. Is this a local min? Yeah. Yes. Because there are no other spots that are lower. It's the lowest that's near it. Okay, so on those weird ones, you have to know like the definitions, the really fine points. Okay, so that's about mins and maxes. And the last thing I need to teach you is about, I shouldn't say the last thing, the last major topic is these. Would you agree that I have attempted to draw an upside down parabola? Now, I totally get that some people think it's decreasing on both ends because there's arrows and they're pointing down, so you can't think that way. You need to know the definition of increasing or decreasing. As you go from left to right, is the graph increasing all the time or decreasing all the time? As you go from left to right, is it only increasing? No, sometimes it increases and sometimes it decreases. Okay, so then there's an increasing part and a decreasing part. And I get it. People look at this and they're like, they're both decreasing. Nope. If you read from left to right, from like here to here, in between the green lines, the left part, that part's increasing. Get how it's a little confusing because it's got an arrow going down, but yet it's increasing? You gotta say that it's from left to right. Okay, so this is increasing. Then how do we like say it? Well, here's a point, 2 comma 8. You would say that this, how do you say it's increasing on the left side? Well, what's the furthest to the left that you can go? Negative infinity, very good. And it keeps on being increasing, like it is increasing all the way until you hit 2. Now I get some people think it's 8. Nope, it's 2. These increasing and decreasing things are always done with the x values. So you know that green line that runs right up and down there, and I was saying it goes between these two green lines? That green line is at 2.
Would it be a bracket or would it just...
Good question. It is so arguable that it should be a bracket or a parenthesis that I will accept both. Because I totally get the argument that it should be included and therefore it need a bracket, or it shouldn't be included because it is stopped right there. And so it's so arguable, I'll take either one. I will say that on most textbooks, they use parentheses for these. They don't use brackets, but I get it, so I'd take your bracket if you want. But if it's a Schoology quiz, go for the parentheses, because not everybody thinks like I do. I actually think I get the argument that it should be a bracket, because if the 2 wasn't there, then all of a sudden, what are you going to, 1.9? You know, like you have to use the 2. So anyway, I'll accept either. But if it's a Schoology quiz, or if you're just talking to everybody else, most people just say use parentheses. Okay, that's increasing, and I write a little ink above it. You don't have to, but you know, you better put it in the right category. That's the increasing part. Well, then the other part must be the decreasing part, right? It's decreasing from, and again, I'd accept brackets, but parentheses are favorable because most Schoology quizzes will be using parentheses. Decreasing from 2, I hope I taught you that use the x values. And I totally get when some kids say negative infinity, but they're wrong. Where's the other green line? Like it goes from here to, well, like over here, which is way over there, which is positive infinity. Remember, we're talking x values. I know it's going down, but then you're talking about down here, which is a y value of negative infinity. These are supposed to be x values. So it's between here and infinitely over there, and that's where positive infinity lives. Okay, so it is decreasing between 2 and infinity. So this is kind of just weird, tricky stuff. I'm going to give you one. You tell me if that's lower, and I'll prove it's lower by saying it's at 4, 1, then this spot, which is at, let's say, negative 1, 2, and then this spot's way higher than all of them. It's at 7, 5. Just answer this question for me. Is there a local minimum? Will you tell, is there a spot that's lower than everything else nearby? Yep, 4, 1 is lower than everything else nearby. Okay. Is there a local maximum? Is there 2 local maximums? Yes. One of them is both the local maximum and an absolute maximum. And I get why people get confused by that. I thought it was a local maximum. If you said it was a local maximum, it is. But it's also the absolute maximum. You can be both. Imagine I gave an IQ test in here. Okay? You know, we all, let's say that the people that make these decisions, I don't know if the American Psychological Association or who does that, but they decide this is a fair IQ test, okay? Give you the IQ test and somebody in here has the highest IQ. And let's say it's really high. Let's say it's like 171. That would be insane. Okay? Could you be the local maximum then? Yeah, you're locally the smartest kid. Could you also be the smartest kid in the world? Could you?
Yeah.
Yes, it's possible to be both. You can be the smartest kid locally and the smartest kid in the world. It's not likely, but it's possible. Point. Some people will get this wrong on the test because they'll just say it's an absolute max and they won't say that it's a local max, but it is both. That point is both locally the highest and overall the highest. All right, for the minimum, it'd be different here. This would be a local minimum, definitely not the absolute minimum. Everybody knows that. But people will say that the absolute minimum is negative infinity, and they're wrong. The right answer for that is there is no absolute minimum. It doesn't ever stop going down. So if I ask for the absolute minimum of this graph, you have to say there isn't any minimum. If you say negative infinity, it's a fine point. So many little arguable points on this, but you're going to lose points if you don't know the right answers. There is no absolute minimum. There's a local min, but there is no absolute min. Okay, now would you list for me the two intervals where it's increasing? You can use parentheses or brackets. Two increasing intervals. Anders, give me one of them.
Negative infinity to negative 1.
Nice. John Paul, the other increasing interval?
It's 4 to 7, I think, is the highest.
You are correct. Those are the increasing intervals. Is there a decreasing interval? Yes. There's an easy one and a hard one. Everybody make the two decreasing intervals. Chase, give me either one.
Negative 1 to 4.
Negative 1 to 4. You use the x values. That's the main thing we look for. Good. And the harder one, you got it? Okay, take your time. This is tricky. Basically, it's this green zone here. And it's really easy to mess it up. Tate.
7
Positive infinity. Very good. If some kid was arguing with you and saying, no, it's going down to negative infinity, you'd have to explain, no, that's the y value. And these are only x values. And so what's way over there? Positive infinity. Okay. I feel like you understand it now. So let's go through these really quick. On this green slide, is that, even though, look at it really close, is that a local minimum? No, it is not. Because in the neighborhood of that point, there are points that are lower. So it can't be a local minimum. All right. Is this spot a local maximum? Yes.
Yeah.
Nearby, it's the highest spot. Then, can you just tell me the increasing and decreasing intervals? We just practiced this. This should be really easy. Let's just do one of them. Literally one. So, let's see. Albright.
Negative infinity, negative 3.6.
It's negative 3.6. You are correct. That is one of the increasing intervals. Okay. And the decreasing interval that's the hardest is this one. You might be like, but they didn't even tell me what point that was. You can figure it out from context. That point is at 1, 0. So therefore, it'd be 1, 2, even though it seems like negative infinity, it's infinity. Okay, next page. A whole bunch of this. We've practiced it enough. Skip it. Next page. The weird kind is this one. I totally get how it looks like you should say that it's not really a minimum because it doesn't have like a dish, you know, like points on both sides of it that are, but that's not the question. Is there any place nearby that is smaller or lower? No. So then it's the lowest of them all, and therefore it's a relative minimum. It's not the absolute minimum, though, because there's places that are lower. That one is the absolute minimum. It's the lowest one. Why didn't we say no minimum? Because there's no arrow. It's a dot. It's a big difference, yes.
So all the stuff for relative min or max
Yep.
always says like within a given area. Are we ever going to be given like an exact measurement of like?
Nope, just on both sides of it. Just look a little to the right of it and a little to the left, because I know what you mean. If you gave an interval of all of this, it might be a different answer, because it's like a much bigger area. But just think one side of it and then the other side of it, and right next door, just right there. And that's a good, smart question to ask, but we just want you to tell don't overthink this. Just look a little to the right of it and a little to the left of it. And is there any spots that are lower? Nope. So it's the lowest, so it's relatively a minimum. Okay, on to this page. This is also mins and maxes. I think we've already got that, so we're gonna move on to this page, page 6. Writing an equation for this. All right, now these are, again, there's one of these things where it seems easy until I hit you with the weird exception. Okay, watch. That's 1. That's -3. The equation for this is not super hard. It's x plus 3, because that -3 there will make it equal 0. Another way to say it is, you do the opposite on the inside of the parentheses, the opposite of what you would think. And then this other one is x, and since that's +1, you use -1.
Why can't you just write the vertex one?
Well, that's an excellent question. You can, but let's just finish this the way I'm doing it, because in a minute, they're not going to be parabolas, and they won't have a vertex. So you're not wrong, but why am I wrong? See, got you on a technicality. Yes?
Did you check for stretches?
Good point. But this one does not actually have a stretch. Go over 1, it goes down 1, so it's worth checking. Yes?
Gotta put the negative in front.
Yes, it's going down on the right, and therefore there has to be a negative in front. That gets so many people, so easy to miss. All right, so then you go, okay, I think I got it. So you're saying that if that's a 1, I should put y equals x minus 1. Doesn't that feel off a little bit? Aren't both ends up? And yet its degree is odd. I mean, what's going on here? Would you agree that this is a parabola? Don't parabolas have x squared in them? So it's squared. Now, why did the other one not have any squareds? Because this one is doing something called bouncing. It's bouncing off of the x-axis. It's at the local minimum. Another way to say it is, it's the vertex. Do you remember that deal with the b squared minus 4ac? And if that ended up being, if the inside of the square root it was 0, then it was the vertex. Anyway, bottom line, you have to understand that when it's a bounce like this, then it's got an even power. And now it gets even more complicated. Life gets more complicated. I mean, they tell you, never fight. Never fight. And yet we have a military we spend tons of money on. What do? They fight people. Okay, so life gets complicated. So, what if, boing, cut through, this one's at -2, this one's at 8. Can you write me the equation for that? There's so many little things you have to remember. You can't just go, oh, it's always the opposite of this number, and the opposite of this number, and that's it. No. It's 2 more things you got to factor in besides that. Sure, it is x plus 2. That's part of it. Can you do the rest? Albright, you think you got this?
Yeah,
Go for it.
parentheses x minus 8.
Excellent. Done? And you fell into both traps. There's 2
Can I?
traps.
Come on, Alex. Oh, is it negative?
Why? Where? What?
Parentheses x minus 8?
Yes, there's a negative in front, but you got to tell me why.
Because it's a regular parabola and then it goes down.
It goes down on the right, so there has to be a negative in the front. Cool, that's one of the traps. What's the other trap? Everybody sees it? Yes.
You need a square.
Yes, because it bounced there. It bounced there, so there has to be a squared there. Man, stuff's complicated. No, it's not that bad. You just get used to it. Now, this is an important one, and this is at the pre-calc level. We ask you to say, what's the lead term of this polynomial? You have to act like you're multiplying it all the way out without actually multiplying it all the way out. If you were an honors pre-calc, we'd actually make you multiply this all the way out. And it's really complicated. You got to have a negative and an x plus 2 and another x plus 2, and then once you get that all FOILed out, then you got to multiply your trinomial by this remaining binomial. But we don't really have to do all of that. All we have to do is get the lead term. I'm going to tell you it would have been negative x to the third. After I multiplied it all out, do you see how the lead term would have been x to the third? Because we got this x and it gets squared, and then it gets times by this other x. Makes it x to the third, and don't forget the negative. Okay, now that means down on the right, and degree of 3 means ends are different. This end is down and this end is up. All right, I have one last thing to teach you. Let me just finish with this. Okay. Have you ever thought of these as turns in the graph? I didn't ever think of it that way, but then they're called turns. I'd like you to think of it as the tracks left behind by somebody driving kind of crazy on the ice. Driving, and then all of a sudden they take a sharp turn and they drift a little bit, and all of a sudden now they're going another direction, and then they take a sharp turn, and these two things are the two turns. This was x to the third, and it's got two turns. Do you see how it's one less than the degree? The degree was 3, there's 2 turns. Let me give you another one. Y equals x to the 5th plus 3x squared minus x minus 1. If I had to graph that, it would have 4 turns. 1 less than its degree. Now let me show you why it has to have 4 turns. I know it goes through -1 because that's the y-intercept, and then I'm going to say I know it's going down on the, or no, up on the right because it's got a positive number in front, and I know it's odd, so I have to be going down when I get to the left side. So watch how many turns I need. 1 turn. Is 1 turn good enough? No, it ended up being up and up. Second turn, is that good enough? Well, it might look like it's right, but you can have 4 turns. 3 turns, 4 turns. 1 turn, 2 turns, 3 turns, 4 turns. It was degree 5, but it has 4 turns. Now let me make it even more complicated because it doesn't have to have 4 turns, but it has to be 4 or less, and it has, because this is odd. Okay, so that 4 turns thing, it's usually 4 turns, but it could be less turns. Let me prove it to you. Here's the graph of x to the third. You've seen it before in higher algebra. Do you kind of remember this guy? X to the third. Would you agree I said, if I just oversimplified it and said, it'll have 2 turns, this doesn't have 2 turns. It's only got 1 turn. And it's even kind of hard to see where it turned at all. So it's got 2 turns maximum. I'll show you why. If I did it like this and it's just kind of more exaggerated, do you get how it's still going opposite directions? As soon as I go to 3 turns, now I'm going down, and that's not what's supposed to happen when they're odd degreed. So that'd be too many turns. Okay, so now you have just learned a ton of stuff about graphing polynomials. Here is your final, do you get this? If I was going to graph this, and I'm going to throw a negative in the front. Could you graph it? Hint, it bounces. It doesn't bounce at the other spot. It just passes right through at that spot. It's down on one end, and I hope you know whether it's down on the other end too. And its lead term is another question we could ask you. If you multiplied it all out, but you don't have to actually multiply it all the way out, what would have been that lead term that sets the degree, sets the lead coefficient? Okay. Hey, you guys signed up for honors. If you were in higher algebra, regular higher algebra, this would have been 3 days of material. Seriously. I taught that class last year. We had taught this, but we would have taught it over the course of 3 days. Okay, so did you know it touched at -4? Raise your hand if that was part of your graph. Okay, it did because of that. All right, next, did you know it touched at +3? Yes? Yeah, you got that? It touches there, but it does more than just touch there.
Bounces.
It bounces there. I'm going to put a B for bounce. You do not have to have that. I'm just trying to remind myself to make it bounce there. Did you have your graph going down at the end because of that negative in the front? It has to be going down when the graph ends. And it has to bounce there. That means it has to go like that. Now, exactly how low does it go? I don't know. It would be pretty cool if I knew the y-intercept, but you couldn't figure out the y-intercept. Could you? You could, because the y-intercept is where x is 0. Do you get how you actually could? You could say that's -3 squared is 9, times 4 is 36, and then it's negative, so it's -36. It actually goes way the heck down there. I'll just stop there because it's getting ridiculous. And then this one just passes through. Now, that spot there must be -36. It's your scale. You can say it's if you say it's -36, it is. Cool. That's the graph. Let's just double check it. What's the lead term? Ooh, -x⁻³. Does that match up with this graph being down and up? Yeah. Does it have a negative so it's going down at the end? Yeah. Okay. The y-intercept was, again, we stuck in the x is 0, and we ended up with -36. It was bouncing here because of that squared right there. How many of you feel like you could get this right on a test? All right. That's about half of you. Let's just try one. Act like it's a test. This is not that hard. Make a sketch of that graph. And wait, change the 4 to a 1. It'll keep my y-intercept way more doable. Okay, do your best. Act like it's a test. So here we go. Watch a pro do this. This is the first thing I did, and I don't know if that's the first thing you did. x² times another x is x⁻³. Is that required? No, but it's smart because then I know that it's degree 3, so one ends up and one ends down. There's no other way to know that. Okay? There's no negative in the front, so it has to end going up, so I go like that. And since it's odd degree, it must be going down over here. Next, I'd figure out the y-intercept. The y-intercept tells me like where it's going to touch. Is it like down there or up there? Well, we'll find out. I put in x is 0 here and a 0 here, and this is 25 times 1 is positive 25. I get some people would think it was negative. It's not. When you have a negative number and you square it, it's positive 25. It has to have a positive y-intercept then. Okay. Now, that's -1. That's important. Put a dot there. That's 5. That's important. Put a dot there. And now is there a bounce anywhere? There is. It bounced right there. Bounce here. Bounce. Touches the 25. Goes down that way. That's somebody who's done a million of these and how I did it. How many of you had something that matched up with that? Sweet. Then you learned what you needed to know for today. Was this graph ever increasing?
Yeah.
Was there 2 intervals over which it was increasing?
Yeah.
What's the decreasing interval? It's very easy to say 25 and 0, but no. Decreasing interval.
0 to 5.
Because this spot here is 0, 25. And this spot here is 5, 0. So it's the 0 and the 5 is the decreasing interval. Okay, cool. Now you have a homework. Your homework is, if I remember correctly, a worksheet.
It's a quiz.
Oh, it's a Schoology quiz? Thank you, my bad. Open up the Schoology quiz. Make sure it opens and it's working. Any questions? Does it appear to be working?
Yeah.
All right, then you get some work time, and that's all I have for today.